Hello everyone, welcome back to Ekraft Geeks. In today's video, we are going to be discussing on the topic Gunn Diode. The following contents we are going to be discussing in this topic are introduction, working, characteristics and applications. So let's begin. Introduction. So what exactly is a Gunn diode? A Gunn diode is considered as a type of diode even though it does not contain any typical p-n diode junction like the other diodes. Here it consists of two electrodes. The diode is also called as a transferred electronic device. This diode is a negative differential resistance device which is frequently used as a low power oscillator to generate microwaves. It consists of only n-type semiconductor in which electrons are the majority charge carriers. To generate short radio waves such as microwaves, it utilizes the effect called Gunn effect. Gunn effect is defined as a generation of microwave power, that is power with microwave frequencies of around a few gigahertz. Whenever the voltage applied to a semiconductor device exceeds the critical voltage value or threshold voltage value. After learning about what is a Gunn diode, let us now know its working. The diode is made up of a single piece of n-type semiconductors such as gallium arsenide and INP, that is indium phosphide. GaAs and some other semiconductor materials have one extra energy based on their electronic band structures instead of having only two energy bands with valence band and conduction band like normal semiconductor materials. These GaAs and some other semiconductor materials consist of three energy bands, and this extra third band is empty at initial stage. If a voltage is applied on this device, then most of the applied voltage appears across the active region. The electrons from the conduction band having negligible electrical resistivity are transferred into the third band because these electrons are scattered by the applied voltage. The third band of GaAs has mobility which is less than that of the conduction band. Because of this, an increase in the forward voltage increases the field strength, that is for field strength where applied voltage is greater than the threshold voltage value. Then the number of electrons reaching the state at which the effective mass increases by decreasing their velocity, and thus the current will decrease. Thus, if the field strength is increased, then the drift velocity will decrease. This creates a negative incremental resistance region in VI relationship. Thus, increase in the voltage will increase the resistance by creating a slice at the cathode and reach the anode. But to maintain a constant voltage, a new slice is created at the cathode. Similarly, if the voltage decreases, then the resistance will decrease by extinguishing any existing slice. Now let us learn about the characteristics of a Gunn diode. As you can see, here is a graph of the characteristics of a Gunn diode. The graph shows the current voltage relationship characteristics of a Gunn diode with its negative resistance region. These characteristics are similar to the characteristics of the tunnel diode. In the graph, initially the current starts increasing in this diode, but after reaching a certain voltage, that is at a specified voltage value called as threshold voltage value, the current decreases before increasing again. The region where the current falls is termed as a negative resistance region, and due to this it oscillates. In this negative resistance region, the diode acts as both an oscillator and an amplifier. As in the region, the diode is enabled to amplify signals. Hence, after learning what is a Gunn diode and its working and characteristics, let us come to the final content, that is application. If you wonder where Gunn diodes are used, they are used as sensors for detecting trespassers to avoid derailment of trains. Gunn diodes are also used as efficient microwave generators with a frequency range of up to hundreds of gigahertz, along with also used as a microwave current generator, that is pulsed Gunn diode generator. Gunn diodes are also used for remote vibration detectors and rational speed measuring tachometers, with which they are also used in microwave transmitters to generate microwave radio waves at very low powers. Along with that, they are also used as fast controlling components in microelectronics such as for the modulation of semiconductor injection lasers. And that was the end of the video on the topic Gunn diode. Thank you so much for watching this video. Don't forget to like, share and subscribe to Ekraft Geeks. Thank you so much and see you next time.